Welcome everyone to this session on knowledge-based applications. You haven't looked at the papers. This session represents a variety of different tools, methods, techniques, which are really about capturing, managing, interrogating, analysing, I suppose, large data sets about the system, the socio-technical system, and the product and variants thereof. So it's quite a mixed session. And while all the papers sort of deal with fundamental challenges, or can be considered to deal with challenges of volume, variety, and sort of quality of data, they all take really quite different perspectives. So I think we're going to have an interesting discussion. For the audience, please do add questions to the chat. And once we've received all the presentations, we'll go back through those questions in the order of the speakers and get them to respond to those questions. I also have a couple of questions which I've thought about in advance, but I would encourage the audience in particular to think about specific questions to do with the domains and the particular tools and methods, but maybe also to think about how our presenters might, what are the common challenges across all the papers and how they might verify, validate, or test and prove some of their methods in practice. So maybe the audience can think about some questions in that respect. So welcome Lee, welcome Sara, welcome Felix, welcome Andreas. We are still waiting, I think, for Youssef to join us. Hopefully he'll be able to do that, or a nominated representative will join us. Everyone knows the etiquette. Again, please use the chat. It makes for you're going to sit through sort of 30 minutes, 25 minutes of slides. Please do add some comments and questions in the chat so that we can make this a lively discussion for half an hour or so. Robert, I think it's over to you if you'd like to start the slides, please.
Yes, okay. Would you like to give an introduction of each user separately, or? You're muted.
Maybe we could ask Sara, would you like to introduce yourself?
Yeah, sure. I'm Sara from Technical University of Denmark. I'm right now in a tenure track position, working on expert system, configuration systems, manufacturing digitalization, and product and manufacturing design alignment. Yeah.
Thank you very much, Sara. Thank you. Okay, Robert, the first slides, please. Thank you.
Hello, I am Sara, and I will present this research entitled Application of Expert Systems for Personalized Financial Decisions on behalf of all the co-authors of the paper. So first, we will look at the motivation of this research, then we'll look at the configurator development, and we will conclude on the research and the practical implications. Product families contain variants of products and their parts to meet the diversity in the market. Actually, the problem is that customers are requiring for diversity. The market is competent. We have a lot of complexity in product and process, and it calls for an IT solutions which is a product configuration system. In this research, we want to build a financial configuration tool for customers based on personalized lifecycle information. And the aim is to improve financial literacy, which will be both feasible and usable. So we would like to look at the growing needs for financial services, looking at the financial literacy and complexity of financial systems. Financial literacy combines financial, credit, and debt management knowledge, which is necessary to make financial decisions. Today, many young adults are experiencing stress when facing their financial situation. And this is because most lack the skills, knowledge, and confidence to do so. This means that around 3.5 billion adults globally, most of them in developing countries, lack an understanding of basic financial concepts, as you can see on this map. Account owners tend to be more financially safe, but plenty of them still lack financial skills. Globally, 38% of account owning adults are financially literate, as are 57% of account owners in major advanced economies and 30% in major emerging countries. We would like to look at the customization of the current system to do a comparative analysis of existing tools and also the ideal financial configuration tool. Hence, we look for available tools in the market, but actually we didn't find many of them. The best one that we found is called Wealthfront, which is an automated investment and wealth management service located in California. It provides banking, automated investment, free financial planning, and by questioning users on their financial goals early on, the tool can provide more customized layouts. You can see it present a high level of graphical visualization and customizability. However, the problem is that it's only available in US. The second tool that we found is called Personal Capital. It's an online financial advisor, which is located again in California. The company provides financial analytics and planning tools. But the main problem of this tool is that it's not personalized. So the level of personalization is not as high as expected. Hereby, we want to develop a configurator which is based on the expectation from the consumers. Hence, we are using design thinking as a user-centric method for developing a configuration system, exploring the problem space and exploring the solution space, and iteratively aligning both spaces by a good understanding of the problem between the knowledge experts, end users, and domain experts. This is just one screenshot of our system just to show and give you an idea about how the system looks. Users can insert the inputs as numbers, integers, or as a multiple choice. We also have hidden typed inputs. For example, if here you says that I have 2 or 3 children, hidden inputs will show up both here and in the next steps. Based on the inputs, we can generate the output page that you can see here. It's big Excel sheets with different sheets, and it gives the user a very good understanding and predictions of their financial situations and decisions in the future. And finally, here we are presenting the results of the interviews with domain experts and end users. And hereby we have 2 different types of questions. In feasibility, we are investigating if we are hitting the financial goals and details. And in usability questions, we are asking about the benefits of configurators and, of course, the usability of the configurator. And we also have 2 main groups of the interviews who we ask questions from. Domain experts who are the experts within product configurations, IT and financial literacy, and of course we have 21 end users who has been interviewed. These questions are asked before and during prototype development. We ask about the good features of the current prototype. They ask or they recommend quick, simple overview of the calculations, and they ask for graphical visualization. We also ask about the feature of the current prototype that we can improve. They all ask for detailed explanation of the tool. And we also ask about additional features that we can add, and they ask for different languages and tailored questions that we can add to the system. We also asked about financial goals that they want to achieve. It was quite adverse. We also asked about the financial details. It varies greatly based on different people, but we listed all of them in the paper. And we also asked how the model interface should be designed. They ask for graphical representation. They ask for more details, interactive elements, and also the most importantly, they ask for autofill from their bank information or their loan information. We also ask about the usability of the system, and based on the numbers, you can see that they are very satisfied with the system. Now we can take a look at the conclusions. To conclude, there is a growing demand for improved financial tools, which is because of the complex financial systems. There are several financial tools already exist, but there's still very little scientific research on such tools. In this research, we proved that it's possible to build a financial configurator with high level of feasibility and usability. However, we only focused on potential and additional work required to expand the financial analysis with various areas such as income, housing, assets, investments in market, and more. Thank you for listening, and I'm looking forward to hear about your questions and also comments.
Thank you very much, Sara. We've got a couple of questions in the chat, which is good. Thank you very much to James. And so we'll pick up the questions, I think, after all of the presenters have presented and just go back through. back through in the order in which you presented. So thank you, Sara. And Lee is our next presenter. So Lee, do you want to do an introduction?
Yeah,
please?
why not? Hi, I'm Lee. I am a doctoral candidate at the University of Bristol with the Design and Manufacturing Futures Lab, which is headed up by our own chair, Ben Hicks. And my PhD is in participatory prototyping and using mixed reality to facilitate it.
Thank you, Lee. So Robert, can we start the slides? Thank you.
Good afternoon. My name is Lee Kent, and today I'll be presenting a video abstract on behalf of the authors of the paper, Prototyping Through the Lens of Network Analysis and Visualization. We are members of the Design and Manufacturing Futures Lab at the University of Bristol. Okay, so prototyping is well established as a critical part of design, and there are plenty of papers evidencing this. Prototypes are unambiguous representations of concepts and ideas, and any learnings from the prototype or its creation will inform the next steps to take. As prototyping can occur either physically or digitally, there is a challenge of ensuring that prototypes, regardless of medium, are captured in a meaningful way. There have been several tools developed to support capturing different facets of prototypes. Some integrate into larger PLM systems, and some are more specific to prototyping. Prototyping capture tools comes with the advantage of providing an opportunity to capture more tacit knowledge that otherwise may be undocumented by the prototype creator. What is still unclear is the utility of this captured data. So this research paper is an exploration into the utility of captured prototype information. It will achieve this by experimenting with different techniques in which insights could be generated about a design process through its prototypes. The research is not looking at the specific information captured with the prototype, but will use a network graph to look at the wider design process and investigate if trends or working methods can be identified. Something to note is that the capture tool and process used to generate the dataset will not be detailed or critiqued in this presentation, as these have been given their own dedicated time elsewhere in the conference and are referenced in the published paper. Having said that, here are some key bits of information and context about the dataset. The dataset was captured using Protobuf, a web app that you can load on either your smartphone or computer. You can then log in and either upload files or take pictures of your prototypes, as well as populating the metadata. Protobuf uses the Grand Stack that comprises 4 technologies in the figure and stores all of the prototypes and designers as nodes in a graph network. In a graph network, both the nodes and the relationships between the nodes, known as the edges, can be given information. The data was captured in the Idea Challenge, an annual week-long hackathon pitching academics and design research labs against each other to tackle global challenges. In the 2021 challenge, 14 designers documented 204 prototypes, providing us with a comprehensive and varied dataset in which to explore. For this investigation, 2 approaches were considered. First, common network analysis techniques were employed, and the second was to use network visualization techniques. Python's NetworkX and the Unreal Engine were used to build the charts and images. One of the first network analysis techniques was basic counting. By comparing the number of nodes to edges, we can see project A and B typically assigned more than 1 creator to most of their prototypes, with each prototype in project C and D typically only having a single creator. This result alone could indicate the level of collaboration amongst the teams. The next metric was to consider clustering, with a modularity score of 0.3 or greater indicating good clustering. From the data, we can see that Team B, C, and D's prototyping processes could be broken into smaller groups of activity, while Team A featured a single large activity with lots of minor activities. Here we have 4 centrality measures. I'll pick out a few interesting points amongst the noise. So with degree centrality, Team A has the spike of connected prototypes towards the end of the design process. The eigenvector centrality is quite noisy, but it has a slight bias towards earlier prototypes, which makes sense as they have more time to be influential to the future prototypes. The closeness centrality is mostly noise, and the betweenness centrality highlights some highly influential tertiary prototypes for each team that could be investigated. It's interesting that these occurred at different points for each team. Now for the visualization element. These 2D charts were created using Python's NetworkX Spring Layout algorithm. The red nodes are designers and the blue nodes are prototypes. We can see one of the designers on the left in Team C tended to work more independently than their two teammates, denoted by the dashed boxes. This is not seen in Team A central layout, where all three of the designers are very close. In the right-hand side, we have charted just the prototypes alone. In this one, it's interesting that there are several prototypes that are completely unattached or orphaned, and this may be through either data entry error or ended up that they just weren't used or uninfluential. They would be interesting to consider in detail, as these aren't necessarily outliers. In this visualization, we considered the data plotted in 3D space. In this instance, each data point is placed randomly at the bounds of a sphere, and the edges are also plotted. The sphere can be explored with a mouse and keyboard, and you can see with every node there is clearly overplotting, and the spring algorithm needs to be implemented in 3D. The plot can be filtered to individual teams using pre-built functions, and in doing this, important prototypes can be found, such as this one. The final prototype in this design process that was influenced by many other prototypes. In this visualization, we considered a 2D data plot in 3D space. As before, the queries are embedded into the platform and the network is interrogated via a user interface. Individual nodes of interest can also be selected and their relationships with other prototypes highlighted. Chronology is clearer with this visualization, and being built into a 3D environment means that data visualization can be ported to augmented or virtual reality, providing novel ways in which to explore the data. With these views, the nodes are currently displayed as cubes with images on, but they could be photogrammetry models shown to scale or as annotated 3D models. So what have we learned? With prototype capture tools, the roles of prototypes and relationships between the prototypes could be investigated. With each of the stages of analysis and visualization, new and differing insights could be drawn about different teams' design processes. I mean, charts exist to make data interpretation more straightforward, so it stands to reason that they are useful to capture and interpret the design process. In this exploration, the content and rationale attached to each prototype was not investigated, but the connections between them were, providing interesting probes and a means of investigation. We have demonstrated what you can do with those captures by using network analysis and visualization to understanding prototyping processes. We were able to identify team working patterns and identify key or influential prototypes. Thank you for watching. If you have any questions, please get in touch.
Well, thank you very much, Lee. And again, please, for the audience, I realise we're only down to about 16, 17 in the audience, I think it is. Please put your questions for Lee into the chat. I can see one already, which is good. Thank you, Lee. And we're on to our third presentation, which I think, Andreas, are you there? Andreas, can you share your video? Make sure you share your video and your sound later on, please, so that we can ask you to respond to some questions. Robert, to save time and maintain pace, do you want to start the presentation, please, for Andreas?
Yes, all right.
Welcome to my presentation, Data Networking for Industrial Data Analysis based on a Data Backbone System. My name is Andreas Eiden, and I will present our research contribution today. And I will present first a short overview. I'm talking about industrial data analytics with an integrated reference kit, then about the data backbone for industrial data analytics, and lastly about data extraction, transform, and load processes to the industrial data analysis. First, if we look at data analytics, many are doing it, and if you have analysis inside industrial use cases, we're talking about industrial data analysis, and the analysis itself is not a big problem, but the data access is one of the main concerns. Because if you look at the image on the right side, you see we have data all across the life cycle, all across different IT systems, at your suppliers, at your customers, and you want to analyze those data, so you have to access it. But with all this scattered and spread across the life cycle, there are insufficient direct links into data analysis. Many people are using Excel spreadsheets or something like that for data analysis, or are copying all the data into huge data lakes. So we think a lifecycle data backend system with direct access into analysis is a good solution to cope with this problem, and providing universal interfaces that translate all the data into required data schemas that are usable by open source or proprietary software can solve it. And we identified different alternatives how you can build up such a data backbone. And the first one is a unified system lifecycle management backbone that you are seeing here on the right side, provided by the company Contact. And inside this system, you can store whatever data you want, from the requirements all across the lifecycle into the usage phase, and all the IoT data. You are very flexible. You can produce all the kind of data you need and you want, and everything is maintained in this one system. And on the right side, you also see an example where you can have all the data of this excavator, like the bill of materials, the IoT data. And this alternative is very integrated, highly integrated, and the analysis results can be stored easily also inside the system because it's so flexible regarding the data. But it's very hard to implement if you're not in a greenfield situation, but where you have existing IT solutions that probably then need migration into such a system lifecycle management backbone. And to cope with this situation, we have a different alternative, the semantic metadata repository that you can see here on the right side, where not the data you work with in engineering or in production or whatever is stored, but links to this data. And this data model allows for fast identification and initial evaluation of data, and then you can jump right into the real data inside your PLM or ERP or whatever system. This means we are very flexible regarding existing data sources. We can connect 1, 2, 10, or 100 systems to this semantic metadata repository, and we can do it incrementally by also providing sufficient usage. And on the contrary, it's an additional system on top of whatever you have. And it's also it's an industrial prototype. The other alternative is a software you can buy and you can really use in the industry. And if we look at the data model for the semantic metadata repository, it aims to create as few overhead as possible. So you see the whole data model on the right side. And it's completely sufficient to identify and access all the data that is stored inside a company, inside all the connected systems. And it's also useful for providing information about the usefulness of data. For example, you can, with our metadata model, you can look in all data sources, like everything that exists with an attribute named price or whatever you want, and whatever you want to put inside your data analytics. And to do this, you have to develop connectors for all the data sources of a new kind that you want to connect, and then arrange the data in form of a metagraph. But if you have done so, then you can build ETL pipelines into data analytics, which means you want to analyze something, then you can provide information about your data analysis needs in a given and developed by us exchange format inside the Accord project. And then you can use the GUI of the lifecycle data backend system to evaluate if suitable data is available inside all the company systems. And if there is available data, our system can transform the data and access the live data via REST, which means that we're providing all the data directly into the analysis via this REST pipeline. And you can check if data is changing because you have additional or new data created inside your systems. All this data is again put into analysis, and the results can be stored also. And so we see industrial data analysis provides powerful methods for the improvement of industrial lifecycle processes, but the data access is scattered and is a crucial requirement. So we built different alternatives for data backend systems where you can access, evaluate, and bring data directly into analysis processes. And all this is right at the moment validated inside the project Accord, which is funded by the Federal Ministry of Education and Research of Germany. And we're validating it in several industrial use cases. You can see the industrial partners on the right side. And the next research question would be the sharing of data across company borders, which is also a highly complex topic. Thank you for your time, and I'm open for questions.
Well, thank you very much to Andreas. And I said Andreas has put in the chat he's struggling to connect. So while I encourage all presenters to introduce themselves so that they do actually speak to the audience, Andreas studied mechanical engineering and is now based at the Virtual Product Engineering Institute at TU Kaiserslautern, where he's a researcher. So again, any questions for our third presenter, please put in the chat. Thank you, James. I can see one's come in. So we've got at least one question for all speakers so far. So on to our fourth presentation, which is Felix. And Felix, would you like to give a brief introduction of yourself, please?
Sure, thank you. Hi, I'm Felix. I'm a research associate at the Laboratory for Product Development and Lightweight Design at the Technical University of Munich. Before I came here, I did my master thesis at the Department of Engineering at the University of Cambridge. That's also where the research, which I will present now, was conducted.
Thank you, Felix. Robert, can we start the slides, please?
Welcome to my talk on the value of information in clustering dense matrices, when and how to make use of information. My name is Felix Endress, and I'm a research associate at the Technical University of Munich. The research that I present today was conducted in a collaboration between the Engineering Design Center at the University of Cambridge and the Chair of Engineering Design at the Friedrich Alexander University Erlangen, where I studied. Nowadays, in our digital world, the presence of highly connected systems is greater than ever before. One can already assume that a characterization of the systems shown on the right, for example via clustering, is not easy due to the density of the matrices. Therefore, in this talk, I will introduce a paper on our research to enhance the clustering of dense matrices, representing highly connected socio-technical systems. My talk is divided into the following sections. First of all, I will comment on the state of the art. Following this, I will highlight some steps in a clustering procedure where measures can be taken to improve and modify clustering results. And finally, I will summarize my talk with a short conclusion. Let's have a glance on the state of the art and the problem that we try to solve. There are several reasons for applying cluster analysis, where one tries to find modules, frameworks, or buses within the corresponding system. To cluster networks, usually clustering algorithms or metrics are used that were extensively researched before. However, when it comes to dense matrices, the clustering requires special attention. And in this talk, the non-zero fraction of greater 50% is used to call a matrix dense, or the corresponding system as highly connected. The first problem identified when clustering highly connected systems is rather obvious. There's a high dependency between the clustering results and the algorithm chosen. For a practitioner, it is hard to select an objective function without knowing the structure of a system. The denser the system becomes, the more important become answers to the questions of how many modules do we search for, are overlaps allowed, and are small or large clusters preferred. Unfortunately, what would be required to appropriately tune an algorithm is the result of the same analysis. Even if our objectives while clustering are clear, ambiguity may still exist. All three clustering solutions shown may be reasonable, but there is still some kind of ambiguity involved. And without knowing the context, several outcomes could be correct. So now, having these two challenges in mind, we try to improve the clustering results in the context of dense matrices. And in the process of a cluster analysis, there are basically three different steps where one can intervene and process the model data, shown here. The first step in the clustering procedure where one can use the modeled information is the pre-processing. We investigated binary thresholds and numerical thresholds that set values below a threshold value t to 0. And binary thresholds, in addition, raise interaction strength above the threshold value to 1. For the experiment, we clustered the same system with different thresholds several times in a row. And after convergence, we looked at the results, and what is shown in the table are the numbers of different results for 2 subsequent analyses. So in summary, the binary threshold showed an explorative character, whereas the numerical threshold simplified the problem, leading to clear but different structures. Following the clustering procedure, the algorithmic clustering comes after the pre-processing. As already mentioned in the state of the art, information are required to appropriately select algorithms to cluster. We found that being aware of 3 categories for the source of density can support the process of choosing a suitable objective function. Finally, once the algorithmic clustering is completed, a manual evaluation of the results is recommended in literature. So one could ask if for dense matrices, where we saw that there are problems with the algorithmic clustering, a focus on the visualization might help to find better solutions. So we ordered elements in a way that transition costs were minimized, which is the difference between 2 neighboring fields in a DSM. As a result, zeros were brought together and modules were easy to identify. For the example of the hand drilling machine, the separation of electric and mechanical components was observed. An experimental evaluation with more use cases is still open, but again, we could highlight the importance of the manual clustering or manual post-processing. This already brings me to the conclusion of my talk. Among the limitations that only a few use cases were considered, some insights were found and are presented in the corresponding paper. First of all, information in a model, but also on a model's context, are very valuable for highly connected systems. We could show that binary thresholds generally have more an explorative character, whereas numerical thresholds require knowledge on the modeling process. Always, thresholds are seen as a very early interpretation of the model data prior to knowing the structure of a system. Furthermore, categories of the sources of density were identified, and the relevance and power of a visualization-based clustering was proven. Last but not least, here you can find the references cited earlier. And with having said this, thank you very much for your attention.
Thank you very much, Felix, for that. And any questions for our 4th presenter, again, please add them to the chat so that we can go back through them. So this takes us on to our 5th presentation, which is by, well, the lead author is Youssef Houchmand, who's a PLM or Product Lifecycle Management Architect and Technical Lead at Mercedes-Benz. Youssef, I don't believe you're in the audience. I can't see your name in the people, and I cannot spot any of your co-authors.
There was recent.
Sorry, Robert.
Sorry. Yeah, there was recently a co-worker in the chat. His name was Patrick, and he said that he has some troubles with the audio, so I instructed him to go to the help desk and sort this out. He might join later.
No problem. Okay, that's good. Thank you, Robert. So we will receive Youssef's slides, and hopefully Patrick will join us if there are any questions for the 5th presenter. Thank you, Robert.
Hi, my name is Youssef Houchmand. I am the technical lead of a PLM modernization project at Mercedes-Benz. In the next few minutes, I will give a brief overview of how we want to transform a monolithic PLM landscape to make it future-ready. This will cover both the challenges ahead and the solutions we have developed to address them. This presentation summarizes indeed the key results achieved and insights gained over the last 4 years. First, I would like to define the term PLM or Product Lifecycle Management. PLM is an approach to holistic management of all product and process-related data along the product or system lifecycle. It is not just about managing data in data silos, but about the seamless integration of all data and information generated along the entire product lifecycle. And the lifecycle usually starts with the early requirements phase, moves through the concept and development phases, and ends at the end of the product or system lifecycle. During the lifecycle, various data are generated, such as requirements originating from the market or from the lawmakers, or various 2D and 3D models necessary for multi-physical simulation. It also includes the data generated during the utilization phase of a product. PLM is indeed a strategic backbone of manufacturing companies. The image here shows the PLM landscape from an application or process perspective. Now the question is, what does the PLM landscape look like from a technical point of view, and how complex is it? If you do some research on the internet or ask the PLM vendors, you will get 5 or 6 names like PDM, ERP, and CRM. But how many IT tools does an OEM actually need to manage the data generated along the product lifecycle? This picture shows the PLM landscape from a technical perspective. We have over 150 systems that are used along the product lifecycle to manage various product data. We are indeed struggling with enormous business and technical challenges here. The technical cut, for example, causes that most engineers need more than 3 to 4 systems for their daily work. The logic is people go to the data or to the data silos. Furthermore, implementing new requirements takes a lot of effort. Because on the one hand, the impact of many changes can be very difficult to estimate, and on the other hand, one change can affect the entire process chain and force the adaptation of several systems. In addition, there exist many interoperability issues that complicate the lives of our data scientists or in general our data workers. A domain-driven redesign of the PLM landscape is our answer to the enormous challenges ahead. This is not about new systems, but about a new philosophy for our PLM landscape. Based on the domain-driven design approach, we are transforming our PLM landscape. Indeed, the key philosophy is user centricity and defining the domains, subdomains, and their dependencies together with the end users in the enterprise. Furthermore, to cope with the complexity of the PLM landscape and to increase efficiency, new applications are implemented using a domain-agnostic infrastructure and based on model-driven software components. Finally, semantic web technology and its philosophy have been used extensively to provide inherent interoperability across the PLM landscape. This colorful slide shows selected domain in our PLM landscape. With these domains, we will replace some important monolithic IT systems in the landscape. This is particularly necessary in order to be able to move from a technical monolithic cut to a domain-driven cut. For example, the functions of the product overview domain are currently distributed across 3 systems. Thus, engineers have to work in 3 different systems on a daily basis, which leads to many manual steps. With the new domain cut, we will combine the functionalities in one domain. We are also consolidating the data scattered in 3 systems into one place as the single source of truth for that domain. Each of these domains has its own data model, its own data storage, and is independently functional because it contains all the data it needs to function, thus changing our perspective from traditional single source of truth philosophy to the nearest source of truth based on single source of chain philosophy. The legacy systems also remain part of the PLM landscape as long as the functionalities have not been fully migrated or the data supply has not been switched over. The migration takes place in a small step so that the supply of the process chain remains intact. Using part domain as an example, I will now dive a little deeper in the next slide and show how a domain is structured and which technologies are used. As already mentioned, each domain has its own data model and its own data storage. In addition, communication with domains takes place via ports. The operational ports are marked with O and are needed for data handling based on business logic, such as create part or check-in part. The data ports are marked with D and are responsible for importing and exporting data. For example, the part data is provided through these ports. Both the operational ports and the data ports are subject to version control and governance to ensure interoperability across the landscape. When it becomes technically or legally relevant, the domain may have more than one database. This may be necessary for manufacturing-related data, for example. The same technologies are then used to serve the subdomains. These are also referred to as data products. Due to time constraints, I won't go into more detail about our platform strategy, the technologies we use, or how the model-driven philosophy enables us accelerate transformation. In conclusion, we can say that one of the most important achievements is that awareness has increased within the organization of both the challenges and the solutions being sought. Furthermore, the first domains are already under development in a user-centric way and based on model-driven development philosophy. As mentioned earlier, we are in the middle of a transition and many more domains will be developed and introduced into the PLM landscape. In addition, the governance model of the landscape will be refined as the landscape continues to evolve and new domains emerge. Thank you for your attention. I would be happy to answer your questions now or also later via email or social media channels.
I say thank you very much, Youssef. You're not here. Patrick has joined us again. Hopefully you can hear me, Patrick. I know you're having some sound issues, as is Andreas. I've watched Andreas and Patrick join and leave this session probably 4 or 5 times each. So yeah, I hope you guys make it and do manage to connect so that you can field a couple of questions that all the audience has asked. What we'll do now is we'll go through in the order of speakers, starting with Sara. There are a couple of questions, and then going to Lee, then Patrick, and then I say Patrick, sorry, my apologies, to Andreas, and then Felix and Youssef. If Andreas and Patrick can't join us, then we'll just go straight to you, Felix, after Lee. Can I ask the Lee, Sara, and Felix, and if Andreas can hear me, and Patrick, to maybe just think about, while the others are asking questions, think about 1 or 2 insights that you've learnt on the way from your paper, 1 or 2 insights that you'd like to leave with the audience, and perhaps at the end, by way of wrapping up this session, I can come back to each of you and you can do sort of 10 seconds and say, these are the main insights from the work that I've done. These are the things that were unexpected or non-obvious that the audience can take away with them. So I'll close the session by coming back to you at about 10 minutes to 3 o'clock. So you can think about those insights while your other colleagues are fielding the questions. First questions are for you, Sara. And as I said, unfortunately, I'll have to read them out because not everyone's got audio access. So the first question is from James Gopsill, saying, thank you very much for your interesting talk. I wonder if more knowledge and awareness of financial planning will make society more or less risk averse. And the second part to that is, I wonder what products designs people will go for if they are more financially aware. There are 2 parts. Thank you, Sara.
Yes, thank you, Ben. And thanks, James, for the very good question. Actually, knowledge awareness and having more financial literacy make the whole society less risky, because when people are aware from their financial decisions and the consequences of it on their future life, it prevents lots of crises, like financial crisis in the whole society, and also prevent lots of broken business and lots of problems in the future. For example, if you are more aware about your pension and you are doing a good investment on your pension, you will have definitely a better life in the future when you're after your retirement. Actually, I'm not a financial expert. I joined this project more as an IT configuration expert. So we didn't do investigation on what people really desire, but on this limited scale that we develop a configuration system and deliver it to the people who can use it, we receive very interesting feedback that they really like the system. And the reason for that is that people have different level of educations and knowledge about financial decisions. And when you deliver a system that can be customized based on their requirements, they really appreciate it. For example, if I can only focus on my pension or on my loan and just get some kind of analysis of the data on what is the best way to go for my loan. Actually, I have an example here. For example, when the banks offer you a loan, normally you just hear that, okay, this loan have a lower interest and I will aim for that. But when you're going through the calculations, you will see that sometimes having the loan with lower interest is not the best idea. Sometimes it has influences on the tax you are paying and all other dimensions of your financial decision. And this tool can provide a kind of graph, for example, for your about your decision on, for example, if you go for the loan with higher interest, you might have it can have better consequences on your financial or on your future finance. So I hope I was able to answer your question. But regarding that what they prefer, we don't know. We just know that they really like this system.
Thank you, Sara. So we have a second question, which is from Mark Goudswaard. Again, thanking you for an interesting presentation and asking whether you thought there was a link between financial literacy and trust in financial institutions. Now, whether that's a inverse or not relationship, I don't know. But what are your thoughts there?
Actually, I think, thank you, Mark, for the question. But I think actually trust and transparency are neighbors. The reason that most of the people don't trust banks or financial institutions is that they don't provide us with transparent data. And it also requires some knowledge from users to be able to understand those data. And the same example from loan. If they tell you that this loan has lower interest, you always go for that, and they cannot teach you or tell you if you go for the loan with higher interest, that will be more beneficial for you. Actually, what we learned during this project is that even when we are offering configurators to the people, there are different. They are asking for different level of details. So it was very sensitive what to provide for different users. So it's the same with banks. They have consultants on board to give you some advices on your financial decisions, but there's still the amount of your finance literacy is really influencing on the advice you're receiving, and they don't know on which level you are located. So I guess these kinds of tools can bring a lot of transparency and clarity about your personalized data.
Thank you, Sara. And my question is probably a little bit of a comment, actually, and it's my own personal experiences of these things in my relative ignorance, is that I discovered, certainly in the UK, there are two models for self-service financial investing. One is run by a company called Hargreaves Lansdown, and their model, they get fees every time you change. The alternative, St James's Place, actually take a portion of your revenue, of the money that's generated, the dividends, etc., and a fee. So obviously in the former, they're encouraging you, there's a driver for you to change all the time. I was just wondering what your thoughts were on those two quite different models and how they might impact the design or the system that you're...
Actually, as I said, I'm not a financial expert, but based on our understanding, actually, what I learned during this project is that because this configurator was only focused on pension data and in Denmark. So we have a kind of a specific tax system in Denmark. We have very specific social secure government help in Denmark. For example, if you have kids, there are a little bit of money that is coming from government into your income, and you're paying less tax. And these all factors, they are influencing each other in a way that it makes it so complicated. In the beginning, when they give me all of this data, and this was a student, we were working together, it was so complicated for me, and I'm not a big fan of looking at financial data. But at the end, what we developed in the system, we figured out that this data can really be translated into some graphs or very simple way of telling people what is the best way to go. About these models, I don't really know about them, but I guess that they don't provide you with transparent data to tell you if you you are paying something in upfront, maybe it's more beneficial to get it from your revenue, because if you have high revenue, they will earn more. But both systems have their own benefits. But the problem is that there is not a system to tell you, okay, if you provide this amount of money with this specific situation that you have personally, how much it can, which way is the best way to go. And if there was a configurator to compare these two models, you were able to get a very good understanding of your decision and what are the consequences of your decision. But normally people who have a very nice analytical way of thinking, they are better than others to make this decision, because they have this comparative analytical way. You know, they are mainly engineers who are very good at it. But the people who are not really good at putting data together and do analysis themselves, they really need a tool to help them, including myself.
Thank you very much, Sara. Thank you. So I think we'll move on to second presenter, Lee. The first question for you was, again, thank you, Lee, for the excellent presentation and interesting work. I wondered if you had any thoughts on how designers might be able to use these insights or visualizations to help them in product development.
Just checking, this is Mark's question, right?
This is Mark's question,
cool.
yes.
Yeah, thank you for the question, Mark. I kind of wanted to tackle this from two approaches. The first one is like basically how the data was captured was very much a reflective capture piece. So as you built prototypes, you captured them and uploaded them. So you didn't plot what you were going to do first. So obviously, because then that's a buildup of data, you get enough data points for it to become useful. So I guess to get value as you're going might be quite difficult, just because unless you're comparing it to your plan, you don't know what the trends or directions are. But what we were able to get through the metrics visualization were team dynamics. So you could see how people were working. And that was quite interesting when you were capturing prototypes and basically who built them. So you could work out what the working trends were and steer how you're operating or how you should start working, or maybe like plug some gaps or something like that, as a means of real-time value. And the second one is trying to use the tool non-invasively. So as you're capturing your prototypes, and that's because the real value really is later, because it's a reflective piece in terms of for compliance or validation, or one of the primary drivers for building it was the loss of tacit knowledge of the people who were actually in the design team. So yeah, you could look at the data and the whole data set on reflection and work out what happened when, and also importantly why, which would be difficult, I guess, to gain value of when you're there actually doing it, because you are the person up inputting it and doing it.
Thank you very much, Lee. Thank you. We've got so just to segue in between your two questions, Lee, there's a second one for you. But before I do that, Thomas Eickhoff has just offered to try and field the question for Andreas. So Thomas, can you able to top right select share your video and audio, and hopefully Robert will be able to let you join and sit on the panel to try and answer the question from James Gopsill for Andreas. I've asked you that now, so you've got it usually takes 10-20 seconds for that to be processed. If you can, that'd be great. Lee, then your second question, which I'll come to, is from Daniel Eike. Lee, thank you for the interesting presentation, Lee. Based on the data set you have used, did any additional insights emerge when going from a 2D to 3D visualization?
Hi, Dan. That's a very good question, and apologise if it wasn't too clear from the presentation. Basically, there wasn't any new significant insights able to be drawn from 3D. And the difference between 2D and 3D, whereas all the information we could get in 2D, we more or less could get once you had put it into a 3D environment. But what was interesting, and what I allude to in the paper, is that the 3D views aren't standardized yet, but it's what you can do with the data once it's in 3D, which is move it into mixed reality with VR and AR. So you can add some context or some scale and depth to what the data set looks like. And that is a whole field called immersive analytics, which is definitely gaining traction. And yeah, I guess it'd be the interesting point will be the usability of those tools and actually being able to standardize how they're presented in the same way that 2D network graph visualizations have sort of become standardized, or the algorithms are certainly settled and known. You don't have to do them all in a bespoke manner. And that's where I think the true value will come from the 3D visualization.
Thank you very much, Lee, for responding to that. So we'll move on to a question for our third presentation, which was data networking for industrial data analysis based on data backbone system. I said Andreas has tried to join. Thomas is going to try and do his best and joined us. Also, Thomas, I believe, is from TU Kaiserslautern. Thomas,
that's correct.
Thank you very much for stepping up into the fore to try and answer the question for your colleague. The question is from James Gopsill, and again says, thank you for your presentation. Looks like the metaverse for design and manufacture. I wonder if you were aware of tools such as GraphQL. The second part of the question then is also, I was wondering if you could discuss any challenges around authorization and visibility of data. In particular, James has experienced some challenges himself, looking at enterprise data around sort of IP sensitivities and ownership and authorization levels and security. So two parts to that, Thomas, GraphQL, and then any thoughts around authorization and visibility of data.
Yes.
Thank you, Thomas.
This part of the question touched on aspects. We are aware of GraphQL. We have decided not to use it. We do have the possibility of later using the query language integrated in the graph database that we use as our metadata store. As a public interface, we will stick to standard REST queries because of better support and eventual possibilities of interfacing with the open services for lifecycle collaboration, OSLC. The topic of authorization and visibility of data is very important. We have a rather simple but general model of roles and access rights, which allows for a hierarchical structure of user accounts with different access rights. So far, it works fine for our toy examples, but we will need some further work until it can be used in a realistic context. I hope this answers the question. We still have some work to do, but we're getting there.
Thank you very much, Thomas. Yeah, James has responded in the chat to say thank you, so I think you've answered that well. So we'll move on now, I think, to Felix, and a question for Felix. But again, Felix, if you, Patrick, I can see you've joined the session again. If you are able to share your video and audio and join the panel, that'd be great. If you're still having difficulties, it might make sense to try and answer the question, which was for Youssef and for your work. In the chat might be easier as we're sort of running towards the end of the session. If you're unable to share and join, and I'll go to you after Felix has answered his question. And absolutely no problems if not. If you could just try and perhaps use a chat to answer the question for James, that'd be great. So Felix, then the question for you from James again. So thank you, James, for all these questions. Crikey, you're doing the job of the chair. Made my life a lot easier. So James's question is: we have done some DSM work, design structure matrices work, in the past, and agree that identifying a best clustering is almost a moving target, especially as the design evolves and the DSM also evolves. I wonder if it is important to provide designers with the ability to cluster different ways, and only when combined with designers' expert knowledge and contextual understanding can a best fit actually be determined. So getting the design or user in the loop, I think, is James's question. How might you do that?
Yeah. Thanks for the question. I guess there are two parts in it. First of all, if it's important to provide a designer the ability to cluster in more different ways. And the literature says yes. They also recommend to apply the different algorithms more often because you have many parameters to tune, to select, and you will always find different solutions. So yes, that's a good thing to do. Basically, there are also two reasons for this. First of all, you might also have some uncertainty in your data. That's why you could do some thresholding, some pre-processing, for example. But as I said, you also have a lot of parameters and different objective functions you could use to find different clusters. And if your purpose is, or your objective is to find different clustering solutions, you should apply as much as possible. So I think it's very valuable to have this opportunity. And the second part then is if it is always required that there's expert knowledge and contextual understanding. I would say no. In an ideal case, we would have perfect data which is free from errors, and we would know exactly what our modularity metric is that we want to apply and search for. Then in this case, which is rather theoretical, I would say, we would not need any external knowledge. But as we saw in our examples and the small use case, as soon as it comes to some kind of uncertainty or these Pareto optimal solutions, we require and we really need some external knowledge and knowledge on the context of the full system. And this really helps. For example, when we applied this transition reduction algorithm, this was without any modularity metric or so. It is simply for the visualization. And there you find also in the literature that many researchers have found out already that decision makers always apply more knowledge than what's actually modeled, so come up with better solutions when clustering a system. So especially in the context of dense matrices, it is very valuable to have an expert with domain knowledge or knowledge on the context or knowledge on how the data were obtained, how we collected the data, and if there are errors included. And I guess that really helps. Yeah.
Thank you very much. Thank you, Felix. I think I do have a couple of questions, but we are very near the end of the session. And Patrick, I assume there's nothing in the chat. I'm going to make the assumption that Patrick is unable to join us. But if Patrick, if you can hear me, again, I can see you joining and exiting. I shouldn't laugh, but you're not the only one. I've suffered these things as well this week. If you can answer James's question in the chat, that's great. If not, no worries at all. So what I said is we've got three of the main presenters. Thomas, you've joined us as well, so you can maybe opt out. John's joined us.
Mr. Chair, Dr. Chair, Professor Chair even. Could I ask a cheeky question?
Of course you can.
If I imagine myself in the role of the designer, the question I often have in mind is the so what question. So if you were to dream a little bit ahead and you've done your research and you could imagine translating it to an extent that might be useful to designers, what would you say to them if they would say, well, so what?
So should we go in order then? Sara, do you want to go? You've got less thinking time for that one.
I prefer to think a little bit about that, yeah. But if anybody is volunteer to go first, yeah.
So Lee has his hand up. He's go on then, Lee.
Yeah, I don't mind going first. I guess the so what of mine, which is the metrics visualization of capturing prototypes, is for designers. It's don't be afraid to use and try the new tools, even if the value isn't immediately obvious. I think what we've done with the reflection, with what we captured is, yeah, it's not necessarily what you're intending to capture, but the insights you could gain were interesting, and they aren't going anywhere. So
what I guess is you might be surprised if you try it.
Yeah.
Okay.
So I mean, it smacks a little bit. I'm filling a bit of time so Felix and Sara can think about it. It's the difference between could I make a product and should I make a product. And lots of people focus on, and companies focus on, yes, I can make the product. It's the should I. which was, I guess, my question at the beginning for all of you. Think about how might you actually prove or test out identify the utility or affordances, and then how might you measure them? So Felix, are you or Sara, who's had enough thinking time?
I think I could answer, yeah.
Go for it, Felix.
Yeah, what we did in the paper basically is like we sketched this full procedure of how to cluster a system. So starting from pre-processing and also including the post-processing. And what a practitioner now could use is using the insights in the paper, saying what happens if I do this at this step in the clustering procedure, and what do I have to expect for an outcome later on. And also with the categories, for example, we introduced, one can find, for example, also modeling errors. One has to be aware of limitations of the own data, or also the granularity chosen. So I mean, the full density of these systems is something which can also be considered in the context of this granularity topic, where you say, okay, if you cannot find a solution with this specific granularity, you might even change it and get a more sparse matrix, for example. So just some insights.
Thanks, Felix.
So Sara, please.
Yes, actually, we did this configurator as a proof of concept. It was a prototype, and it was a research project. So we did it with a medium-sized company in Denmark, and there was no hope that they are going to continue with this project. So we just did it as a proof of concept. And in the middle of the project, when we start to work with design thinking, talk to stakeholders and different users all the time to be able to have this iterative design of the system, we noticed that there are so many interests coming from their users. And this opened the door that they came on board, and they start to help us with the project. And actually, they decided that this is something that they should go with it. And right now, it is they are working on it to improve it in a larger scale, to be able to offer it in the market as a real system. So they are still in the development phase, but I think it was very successful because the usability and feasibility results from the interviews prove that there is call for such system, at least in Denmark. But at the same time, it proved that there are so many limitations about the data, financial data we are getting based on the geographical situation, educational background, and all of this. And that's why we are doing the customization and clustering of the system in a higher level to develop it for different levels, in different levels of details for different categories. And we can deliver a specific system for different groups of people. So, and also for this system, we only work on the pension data, but they are also working right now on the loan data because if all of this data, the metadata from the financial background is not connected, if we cannot even get some data from the bank and from the loan information, the system is not gonna be the best system that users will appreciate it in the future. So they are also working to get interconnectivity of the data in the future as well.
Thank you, Sara.
Thank you, Sara.
And I don't want to leave someone out, Thomas. I mean, it's unfair. You don't feel the need to say, I can't answer the question. I realise you stood in for Andreas, but John's question was, you know, what the so what, and what would you say to designers? Is there anything? Are you able to give us an opinion or view on that? I'm going to assume that's a no, Thomas, and don't worry about that at all. And apologies for putting you on the spot. So there were no other questions in the chat, so I'd just go back to Lee, Sara, and Felix, as you're the three who are with us now, just to leave us with, you know, what were a couple of insights from your work? What have you learned, and what would you want the audience to leave this session with? I won't go in. Well, Sara, are you happy to go first?
Yeah, sure. Actually, we as designers, it doesn't matter if you are a designer of a product, process, service, or an IT system, whatever it is, we tend to think that we know everything, and we just start to design something for our users without considering them. A learning point from what I did so far in the working with, because I'm completely and directly working with industries when I'm running a project, working with different industries has been proved to me that it doesn't matter if your users are just normal end users in the market or engineers. You have to think about them first. And that's why since 2017, whenever I want to do a project, first of all, I'm doing a kind of big research on the market and the users of the system, rather than thinking about my own expertise on how I can design the system. So what I learned during this project, again, for after several times, again and again, I think it's that having user-centric design is my main concern, actually, and is the factor that can make a system successful and sustainable also. Yeah.
Excellent. Thank you, Sara. Lee, what's your elevator exit?
Cool. So this data was captured using another system for the pile of PLM systems that needs to be made interoperable. Sounds like a job for Youssef. But yeah, by capturing prototypes using it, you could not just capture information about the prototype, you could capture tacit knowledge around why it was made, but also you could get information about team dynamics. And using common visualization and metrics in 2D, you can generate some interesting insights. And 3D, and moving into 3D is not quite there yet, but what you can do with it is interesting and potential novel space, but there is a lot of space for research there.
Thank you very much, Lee. So Felix, do you want to close off the session with some wise words, please? Thank you.
Sure, yeah, I try my best. A key insight from my research here was that some knowledge of data, where it comes from, where our modeling errors and so on, is quite important to knowing what can we do with the data, where does it come from, and what's the value of these information inside these matrices. And on a more abstract level, it's most probably what's actually our objective. Is it, especially in clustering, is it the process of clustering, like getting knowledge while doing several analysis, or is it simply one result? I would say it's rather the first one, that the way is, so to say, also the goal in these cluster analysis. And if it's only one result, one might also wonder if, like, the mathematically optimal solution in the clustering might also depict reality the best way. That's also an open question. I don't know if these were wise words, but I guess this is my final state here.
Thank you very much, Felix. And I think the internet's telling us something, because you did break up a bit then, and I'm not sure if I'm also breaking up. But sorry, colleagues are calling. You can't get away from Teams. I apologise if you could hear that ringing, all of you. But just to say to our speakers and to the audience and participants, thank you all very much. That was a good, lively session, particularly for our presenters today. I think there were quite a few questions around where you take your work next and how you might evaluate that and get the users. And some of you asked Sara, you talked about user-centered and getting the users involved. I think actually, really thinking about how we can take these techniques and how we can really establish the value in the context, and it might be something that's surprising. It might be something, particular hypotheses that need to be tested and measured in some way. I think that's really important. I remember Sir David Payne once said the only way you can really understand the next research questions is when problems are pushed back from users and industry. And I think, again, there were wise words. So thank you all very much. Again, thank you to Andreas and to Patrick for your perseverance in trying to join the session. And really, sincere apologies that the system prevented you or inhibited you from joining and contributing to the discussions. So thank you all very much. Lovely to see you all. Enjoy the next session, which is the last session. So thank you all very much. And thank you to Robert as well for excellent moderation and looking after everyone. Thank you.
Thank you.
Yeah, thanks everyone. Thanks, Ben.